What are temperature, heat, and the Kelvin scale? To tell the day is very cold or very hot, we usually say it is or isn't hot. However, in physics, that is not the best way to express it. Instead, we use temperature. To avoid confusion, heat is the thermal energy that flows from one body to another due to the temperature difference between them, always flowing from the hotter body to the colder one. Temperature, on the other hand, does not measure the heat of a body. It measures the degree of agitation of the molecules that make up that body. Take ice at approximately 0 degrees Celsius, for example. It is in a state of low particle movement, which is why it takes a solid form. When we put it in a glass, the energy exchange with the environment causes it to melt. It gains energy from the surroundings to become liquid, resulting in a higher degree of particle movement. If we now take the water from that glass and put it in a kettle to boil, we are adding energy, so these particles move even faster, causing boiling. But if temperature measures a degree of particle agitation, is there a temperature where they simply stop? Theoretically, yes. The scale that best represents this is called the Kelvin Scale, which, by the way, is the standard scale of the International System of Units. The scale was named after William Thomson, the first Lord Kelvin. Although some people say degrees Kelvin, this usage is incorrect. While degrees Celsius and degrees Fahrenheit are known as measurement scales, Kelvin is known as a unit of measurement. Science has observed that there is no maximum temperature a body can reach, only a minimum temperature. In this case, it is 0 Kelvin, absolute zero, which is approximately minus 273.15 degrees Celsius. But, like everything cool in physics, absolute zero is impossible to reach. It represents a state where there is no particle movement. However, it is observed that particles continue to vibrate and possess kinetic energy even at absolute zero. The Boomerang Nebula, located 5,000 light-years from Earth, holds a record for the lowest temperature ever recorded outside a laboratory, registering just 1 Kelvin. This is lower than the average temperature of the universe, which is around 2.5 Kelvin. The record for the lowest temperature ever reached was 100 picokelvin, or 0.0000000001 Kelvin. But why is reaching such a low temperature so important for science? The answer is that some of the most interesting phenomena occur at low temperatures, such as the Bose-Einstein condensate. This demonstrates, for example, that when particles reach a low-energy state, they form a new phase of matter. In addition to the Bose-Einstein condensate, superconductivity, where matter has no electrical resistance, and superfluidity, where a fluid's viscosity is zero, are only observed near 0 Kelvin. And with that, we just learned a little about temperature, heat, and the Kelvin scale. If you enjoyed the video, please leave a like and comment. Follow us and share if you can. Thank you for watching.